Welcome to Math with Malia. Today we're doing Savvas enVision Algebra 1, Topic 9, Lesson 1, Solving Quadratic Equations Using Graphs and Tables. After this lesson, you'll be able to use graphs and tables to find solutions to quadratic equations. For the exploring reason, we have this diagram, and it's recording the path of a golf ball hit from the ground. And like other vertical motions, it follows the shape of a parabola. Part A, what point represents the golf ball before it is hit off the ground? So here is where just before it's off the ground, and if this is on the coordinate plane, we know that this is at point 0, 0. It's at the origin. What point represents the golf ball when it lands on the ground? So here it is over here. We see that it is at 200, 0. Again, 0 is the height above the ground. So we can know that it's traveled 200 yards from where it was first hit. And these are also, if we're talking about the coordinate plane, these are called the x-intercepts, right? Well, this first point 0, 0 is also the y-intercept, but these are intersecting the x-axis. So these are important points when we are talking about quadratic equations. So how can graphs and tables help us solve quadratic equations? A couple definitions. A quadratic equation is an equation of the second degree, so we're going to have this x squared. We're going to have a squared term, just like our quadratic functions. And notice that it's set equal to 0. Okay? So the related function is just that expression, that quadratic binomial. It can be a trinomial as well. So it's that quadratic expression equal to the output. But when we are looking at solving quadratic equations, we're looking for when the output is equal to 0. So when the output is equal to 0, that is what's called the zeros of a function. It makes sense. So basically just looking for the x-intercepts of our parabola. Okay, so the solutions of a quadratic equation. So the equation is what's written, and the function will give us the graph. That helps you with the definition between an equation and a function. Remember, all equations are not functions, but all functions are equations. Okay, because in order for it to be a function, it has to pass the vertical line test, where the graph only crosses through a vertical line one time. We get one input, gives us only one output. So a function is a specific type of equation. So when we're looking at solving quadratic functions, we're looking for the x-intercepts, or when the equation itself equals 0. So let's find the solutions to this quadratic equation or function. Okay, so here's the equation. It's a quadratic trinomial, and if we're thinking of our special cases, we could recognize this looks like a perfect square trinomial because my first term is a perfect square and my constant is a perfect square, so we could factor that using our special cases rule of perfect square trinomials. And we can graph it by typing it into our graphing calculator. And if we're looking for where that equation or where that function crosses the x-axis, or where the output, where y is 0, that will give us the solution, or the 0 of the function. So when we graph it, we can see that this function only crosses the x-axis at one point, right here at 7, 0. Now, why is that? Well, if I factor it, let's see. So remember our special cases rule for perfect square trinomials. I know it's going to be x, and then to get 7, or to get 49, I'd do 7 squared. My middle term is negative, so my binomial squared is going to be x minus 7 squared. Okay, I know I didn't need to do this part, but I was showing you. And so then if that is equal to 0, to fill in my equation, take the square root of both sides. X minus 7 equals 0. What do I do to solve for x? I add 7, so x equals positive 7. That means in order for the output to equal 0, my input has to be 7. Okay. So looking at the graph, we can see that is the x-intercept. That is where it crosses the x-axis at 7, 0. There's only one x-intercept. Sometimes our parabolas go down and cross the x-axis and then come up and cross the x-axis again. So we would say that the solution then, the solution to this quadratic equation is the value of x at the x-intercept. So x equals 7. And we're going to go over again and do some more examples of how to solve it algebraically like I did here, but I wanted to show you the relationship between factoring, which we've already done, factoring trinomials, and these zeros of the function or the solutions to the quadratic equation. So here's another trinomial. Now, is this a perfect square trinomial? It is not. So if we type this into our graphing calculator, if you go to y equals, we can type in x squared plus 3x plus 7 and we can graph it. And we can see, here's an example where the parabola does not cross the x-axis. Okay. The minimum is up here at positive 5, at y equals 5. So it's not going to cross the x-axis. There will be no solutions. So just like with linear equations, there can be one solution, there can be infinite solutions, or there can be no solutions. With quadratic equations, we can have 0 solutions or 0 x-intercepts. We can have one solution or 1 x-intercept. Or we can have 2 solutions or 2 x-intercepts. Why is that? Well, because the parabola goes down and comes up. Or if it has a negative coefficient in front of the x term, if a is negative, then it will go up and then come down. So it will only cross the x-axis at most 2 times. So we're going to use graphing to find the solutions to these equations. So let's get out our graphing calculator and we're going to type these into y equals. So on your graphing calculator, go to y equals, make sure your plots are not highlighted, and then we're going to type in the first equation, x squared minus 36, that's our function, okay, and we're looking for where it equals 0. I'll do the other one too while we're at it. The second one is x squared plus 6x plus 9, okay, so let's graph. And see, the blue one was A. So A, we can see we have 2 x-intercepts. It crosses at 2 places. So we can calculate the zeros by doing second trace, and you can see the option number 2 for zeros. Don't choose intersect. That's where the graphs cross each other. We're looking for the zeros or the x-intercept. So hit number 2. And it says the left bound, meaning go to the left of where the x-intercept is. So I'm going to move my cursor to make sure it's over here. It's still way below the graph. It needs to come up. Okay, there it is. So I'm going to go left to the left of where the x-intercept, hit enter. Then it says the right boundary. So now I'm going to move to the right of the x-intercept. And you can see there's one intercept at x equals negative 6. So we have one solution. We're going to do the same thing. Second trace, calculate the 0, and now we need to move the cursor over here, so I'm going to just move it so that it's going up this side. So it's already in the positives, x is positive, so I'm going to hit enter for the right bound, or the left bound. So there's my left boundary. I need to move my cursor up, so the right boundary is past the intercept, hit enter, and then it says guess, move it back a little bit. There's my second intercept at x equals positive 6. So there are my 2 solutions for the first equation. And we can see that because it's a difference of 2 squares. So it should be x minus 6 and x plus 6. That means x would equal positive or negative 6. Let's do the same for the second curve, the red curve. That was x squared plus 6x plus 9. That's the red one. We can see it appears that it only crosses once. So let's calculate. Second trace to calculate the 0. So the left bound, make sure you go up to get on the other curve. Left bound, I need it to be to the left of where the intercept is, left bound. So I'm looking to set up the intercept is somewhere in between these 2 boundary lines that I selected. So the solution is at negative 3. That's the only one we have. And we could check if we wanted to zoom in right there. We could see that it's only going to cross once. So again, our solutions for the first curve, the blue curve, it crossed the x-axis twice. So our solutions were x equals 6 and negative 6. And for the red curve, It only crossed once at x equals -3. Be thinking of how you would factor this trinomial. It's a perfect square trinomial, so it's going to be a binomial squared. Example 2, using the table feature on our graphing calculators to find the zeros. So here's another way to do it. If you don't want to use graphing, you can type the equation into your y equals and then do second graph to get to your table feature. And then you're just looking for where y equals 0. And there might be 1, there might be 2 places, or there might be 0. Okay, so the solutions for this equation, they typed in y equals x squared minus 7x plus 6. There's your quadratic expression. And we're looking for where the output is 0. Again, you're using second graph. So instead of graphing it, you hit shift and you'll get to your table feature. And then you can search for where y equals 0. Here's another trinomial. Here's another quadratic equation. We have 3x squared plus 5x minus 2 equals 0. So we type that into our y equals, into the graphing calculator. We used the table feature, we did second graph, and we got this solution. To get 0, the 0 of the equation is when x equals -2. But is that the only one? Okay, this is not an easily factorable trinomial, so let's maybe zero in a little bit. Notice our x values increase by 1. We can change the setting of the table. So you want to hit second window, and this will get you to the table set feature. And then you can change the limitations of it, and I'll show you how to do that on your graphing calculator. So here's the equation in y equals, and I do second graph to get my table. And I can scroll up and I can see where y equals 0 at -2, but I want to zoom in a little bit. Maybe it might be very, very small and it might cross twice. So let's go to second window to get to our table setup. And it says it starts at -4, but this one is what we want to change. The change of table, we want my intervals, instead of to count by ones, let's change it to counting by quarter points. Okay, so we're just really zooming in. And now go to second table, and you'll see now my x values change by 0.25. So we can scroll down and we can see it crosses right there at -2. Is that it? Uh-oh, look what happened. It's going more negative, and now it's going back up. So it seems like it goes from negative to positive right here. There's another place I have another 0. So I have another solution somewhere in between 0.25 and 0.5. So we want to be very thorough and not just jump to the first 0 that we see in our table. You can zoom in more and change your intervals for your x values and double check and make sure you check where it goes from negative to positive. Try it number 2, find the solutions for this quadratic equation using a table. If approximating, give the answer to the nearest tenth. So first we're going to type it into y equals, and then we're going to use second graph. So on your graphing calculator, go to y equals, type that in, 4x squared plus 3x minus 7. Okay, and we're not going to graph it. We're going to hit second graph to go to the table. All right, we already see I still have it set to 0.25, so that's good. I have a y equals 0 at -1.75. There's 1. Let's make sure we check. Okay, it's getting more negative, more negative. Oh, now it's going back towards 0. And it looks like there's another one at +1. Okay, so my solutions would be +1 and -1.75. And remember, I still had it set. I'm going to show you my table set. Second window. I still had it set to go in intervals of 0.25. Example 3, application using approximate solutions. Anastasia hits her golf ball off the tee. The height of the golf ball is modeled by this function. So we have a quadratic function because it's going to travel up and then come back down following a parabolic shape, where x is the number of seconds after the ball is hit. So pay attention to that. It's not distance from where it's hit, it's the number of seconds that it's in the air. How long is the golf ball in the air? Meaning from where it's hit, starting at 0, 0, to where it lands, starting at 0, something. We don't know where that is. So first, let's type this equation into our graphing calculator. So typing this into y equals negative 5x squared plus 25x plus 1, and then we can graph it. Once we've graphed it, we can see there are two x-intercepts. Okay, and it makes sense that the first one is at the origin, 0, 0, so we need to calculate the other intercept that tells us when it lands. So remember how to do that. Second calc, or second trace, to get to the calculate feature, we're going to calculate the 0. I'm going to move my cursor over so it's coming back down and still to the left of my intercept, and then move it down so it's below the intercept, somewhere in between. My intercept is at 5.039685. So we can round that to 5.04. So approximately 5.04 seconds it's in the air before it lands and hits the ground. So using a graph is helpful because we can think of the travel of the ball, leaving the ground and then coming back down, so we can visualize the path of the ball through the air. Try it number 3. At the next tee, a golf ball was hit and modeled by this quadratic equation. When will the golf ball hit the ground? Let's go back to our graphing calculator. We're going to type this into y equals. So y equals, type in our equation, negative 16x squared plus 11x plus 6, and we're going to graph it. Okay, and now if you look, you can see it does not cross the first time through the origin. So it's not starting at 0, 0. Let's calculate how long it's in the air. So second, calculate the 0. Let's look at the second one. Okay, so there's my left boundary. There's my right boundary, somewhere in between. I have a 0 at 1.0, about 1.05 seconds is when it hits 0. Look at the y value. It's very, very close to 0. Negative 1 times 10 to the negative 12. It's pretty much 0. This trinomial is not very easily factorable. So we could say the golf ball hit the ground approximately 1.05 seconds after it was hit. We made it to the concept summary for solving quadratic equations using graphs and tables. Your graphing calculator is going to be very useful for this lesson. Remember, we can write a quadratic equation in standard form, like our trinomials, but we're looking for where the output is 0, so it's going to be equal to 0. Okay, and it will have 0, 1, or 2 real solutions, meaning x-intercepts. They're also called the zeros of the function. So if we're looking at the graph that the function will give us, it's where the graph crosses the x-axis. If you have any questions, put them in the comments. Make sure to like and subscribe, and come back for lesson 2.